Okay, so starting from this chapter, we're going to move to a quite different model. In the previous two chapters, we were talking about a model where they were basically one model there, right? We sort of combine the two rows in the economics into one model in chapter 5. And that model is a very simple version to model the whole economy. So the key variable there is like something like production or labor or capital, right? Okay, and but here we're gonna focus on something that's more detailed, which is unemployment. And I mean, in sort of undergrad course, you probably have learned this. You know what's the definition of unemployment, which we will come to that definition real quick anyway. And you will, sort of understand why there's unemployment, basically. Something like you may even learn terms like nature rate of unemployment, something like that. But you don't really have a model that tells you why there is unemployment. Okay, so here, we will show you actually not just one model, but two models that both explain the phenomena of unemployment. Why we're going to have two models? You will see that one of the model, it is dynamic model, so that it can capture the dynamic feature of this phenomena. Okay, what I mean is unemployment is not a stable thing. It's not just today some people are unemployment, because tomorrow some people might find a new job for those unemployed. And even for those who are employed, there's a chance that they quit or they've been fired. So tomorrow, the number might change. So this is a dynamic process. But make a one-period model dynamic, make the problem more complicated. Okay, so in that small model, the dynamic one, we're gonna only consider a one-side model. Okay. Only the supply side. The supply side. But obviously, unemployment is not just one thing. It's not just a one-side thing. It is a two-side thing, right? The demand of labor and the supply of labor happens together to decide how much unemployment we have, or on the other way, how many people are employed, right? So in this the second model, we're going to consider a two-sided model. But because two-sided make the thing complicated as well, so we're going to drop the dynamic feature. We're going to consider just a one-period model. So you see, there's a give and take, a trade-off. In one model, I make it dynamic. Actually, not just dynamic, it's going to be an infinite period model. We're going to use the dynamic programming method you learned from TA session. Okay? And the other one, we're not going to use a dynamic feature, but we're going to add a row in the model, make it a two-sided model. Okay? So, just like the previous chapter, we sort of let you understand the key question there was what caused the economy to growth, or to actually not to growth, but what caused the economy to go up and down, deviate from trend. And the general big answer was caused by total factor productivity. That's the key takeaway from the previous chapter. here we also want to link the real world data to the model we have right now. So we first need to know the key facts about the unemployment rate, the participation rate, and the so-called employment population ratio. Okay. And we will tell you a curve. You probably didn't learn it before. It's called the Beverage Curve. And let's just see the curve and see what happens to the curve in the past few decades. And then I'll show you the one-sided model. We call this model a search model because in this model, the people who are unemployed are searching for a job. Okay. And then we will show you how this one-sided search model determines the unemployment rate. And we will then show you when other factors change, what happens to the model. Very similar to what we did in the last chapter, right? We show you, for example, like when lump sum tax increase, what happens? When total factor productivity increase, what happened, right? Okay, and after the one-sided model, we will construct an equilibrium in the two-sided search model. And we'll use this model again to explain, what happened if some other factors change. Okay. So let's first define some key labor market variables. We said that N is the working age population. That means everybody, let's define the working age, say in Taiwan, I think it's 18 to 65. No matter you're a woman or man, okay? I think it's around that age. Okay. Then the total number of population within that age range, that's N. Q is something we call the labor force. Q is a subset of N. Or I should maybe use the less or equal. Or the number Q is less than N. Some people are within this working age population, but they are not in the labor force. Okay, for example, you guys are not in the labor force because you are students. For some of you, after you graduate, or maybe you have done so, you may go to join the military. When you are doing your military duty, you are also not in the labor force. Okay, so that's something we can define by some rules. But anyway, there are some people who are in the working age population, but not in the labor force. And the labor force can simply be divided into two groups: the employed and those who are not employed. We call it unemployed. And we say that U is the number of unemployed. Okay, U here is the unemployed. You will find it quite interesting is that we don't really have a variable that's employed. Because, well, in some sense, economists don't care about the employed that much. We want to lower the number of unemployment. That's the key variable that people care about. And since we have the labor force, and this is employed plus unemployed, and we know this is unemployed, that's U. So if we want this, that's simple math, right? Employed is simply Q minus U. That's the employed. So we don't really need a term for that, a variable for that. And what we meant by unemployment rate is not working age population and how, what's the percentage of working age population who's not working. We're talking about the percentage of labor force, people in the labor force that are not working. So it's U divided by Q. And Q divided by N, that's the labor force out of the total working age population. That's called the participation rate. There's another important reason why some people are not in the labor force I forgot to say. This is sort of a trick, but basically all over the world, the government define those people who are not trying to find a job, not in the labor force. If you're not trying to find a job, you're not in the labor force. For example, if you are a housewife or a house husband, okay, you take care of your kids or your sibling or something, you don't work. I mean, you're also not trying to find a work. Your work is housework. Then in that case, you're not in the labor force. So in a way, people can decide whether they participate in the labor force or not, right? In that case. So that's why we call this rate the participation rate. And the employed over population ratio, that's by definition, employed is Q minus U, and the population is N. So Q minus U divided by N, that's the employed population ratio. You don't really need to memorize this, just give you the idea, okay, so that later on you can come back and check. And this is the unemployment rate since after the Second World War in the United States. Okay, and it is okay. Here you can see that the unemployment rate is increasing until maybe 80s, and then decreasing after that. I mean, there are bouncing around the trend, but the general trend is go up and down. Okay, that's the general fact. And if you see this, this is deviation from trend. We talked about this last time, I don't know. So that's, the red line is 0. Okay, we're not talking about the total past. This is deviation from trend, or we divided the trend. And you can see that here the blue line is unemployment rate and the green line is GDP. And you can see when GDP is low, unemployment rate is high, right? You can see that, right? For example, here, this is really low GDP and really high unemployment rate. Here. Okay? So basically, unemployment rate is counter-cyclical. Counter-cyclical is just a term we use this to describe when a variable is sort of moving negatively correlated with the GDP or economic growth. Okay. How about the labor force participation rate? Okay. So back in the 50 or 60, the participation rate is actually around 60%. So only around 60% of the total population is actually in the labor force. And it goes up a lot all the way until 2000 and then drop again. But right now it's still higher than 70 years ago. So what happened? If you sort of separate the men and the woman, you can see that the men's labor force participation rate is actually always decreasing. And the woman is rising until around 2000 and then gently decrease or stay around the same. So you can see that in the past, from 1950 to 2000, those 50 years when the labor force participation rate grows very quickly, it was due to, everything is due to women. More women is joining the labor force. In fact, the men is dropping out of the labor force, although the rate is not that high. So everything was due to women. And in the past 20 years, the participation rate is declining, was mainly driven by men and slightly driven by women's not that high participation rate. Okay? And if you see the this is percentage deviation from trend. So this is not just deviation from trend, but this percentage change. Okay, so divided by 100. This is okay. And you can see that here GDP is the blue line and the black line is the participation rate. And when the GDP is high, you can see that the participation rate is also high, right? But it's not as high as the GDP in terms of percentage. So we say that it is mildly procyclical. Procyclical is the opposite of countercyclical. Mildly means that the change wasn't that big in terms of absolute term. Okay. Okay, so this suggests that there's a recent decline in the labor force, like we just saw. But because labor force participation rate is mildly procyclical, it is only mildly, right? So it shouldn't be the case that this decline in labor force participation rate is due to this recession. Okay. Also, the recession, but in this textbook, the recession he's talking about is not the COVID-19 recession. Okay, it's about the previous one. So when the book is talking about it, the recession is sort of mostly recovered. So if it is due to the recession, then the labor force participation rate should come back already. But it didn't come back. That's the main argument. Okay, so it suggests it is a long run, more of a long run phenomenon. Okay. And this is labor force participation rate and the employment population ratio. The black line is the participation rate, like we already saw. It goes up and then down, right? And the blue line here is the employee over population ratio. Okay, and you can see that during the recent recession, the 2010 recession, the employee over population ratio dropped by a lot. Okay, what it means? It means it is not that people are drop out of the labor force so that the labor force participation rate go down. Not just that. It is drop out of any work, basically. It's not employed at all. It's not that they were not trying to find a job, but they're just simply not employed anymore. So they really lost that job. Okay, and even after the recession, it didn't really come back to the previous level. That's the main cause of this drop in the participation ratio. Okay. And we're going to use this actually in the second model, but we're going to first define this variable first. We define A as the aggregate number of vacancy listed by firms. That means how many job posts there are. Suppose one job post has one job offer, okay? How many job posts there are for the people who are seeking for a job. So suppose there's only one place to find a job. That's the 104.com, okay? And you go there, you can use the search for all function, list for all the job listed there. You count the number of job offered there. That's the vacancy. Because those jobs haven't been filled yet. That's why the company are looking for people to fill those vacancies. Right? So that's aggregate number of vacancy. And we define the vacancy rate V as A over A plus Q minus U. Why do we define it this way? So Q minus U is what? Labor force minus unemployed, which is what? Employed, right? This is employed. Okay. So employed plus A that's the aggregate number of vacancy. Employed plus vacancy, that's what? Yeah, total number of jobs. You can think of it as there's a company, suppose it has a total number of jobs of 10. And he has already employed 7 people. That's the employed, 7. And there's 3 jobs that hasn't been filled. That's the aggregate number of vacancy. That's for one firm. But if you aggregate over all the firms, the same thing applies. Right, so employed, no matter if that's a job post, a job position that's already been filled, then if it is already being filled, that's employed. If it hasn't been filled yet, that's a vacancy. So if they add it together, that's the total number of jobs. So number of vacancy out of the total number of jobs. That means basically the percentage of job that hasn't been filled, right? And we define that as the vacancy rate. Okay? Okay, and later on you'll see that in our two-sided search model, the second model that we may be talking about today or maybe next week, the vacancy and the unemployment are going to play important roles because we're going to talk about two-sided. And you can see that if from past data, this is unemployment rate, this is vacancy rate, they're sort of negatively correlated, right? So in essence, our model should produce that as well, should produce that fact. Or put another way, our model should show that when unemployment goes up, the vacancy goes down, something like that. Okay? And now let's define something called a beverage curve. So what is a beverage curve? Well, I mean, put it simply, I mean, it is just a relationship, actually a negative relationship between vacancy and unemployment. I told you there's a negative relationship, right? And here, this one dot here, this dot is a combination of one season or 1 year unemployment and vacancy rate. So there could be a lot of years, right? Actually, this is, I think it's one season, so it says December. Okay, so for 1 year, there will be 4 points here. And if you connect the dots based on which year, which season, you will get the black line you see here. You can see that it's, well, first of all, it's negatively correlated, right? Another thing you can see is that it seems like there are 2 lines. These data are around the time before the recession, before the 08 to 09 recession. These lines are all after the recession. It seems like the beverage curve shift out. What do you mean by it shift out? It means given the same levels of vacancy, say 2.5%. Okay. Originally, the economist can give you a prediction by correlation data by this beverage curve and tells you then unemployment rate is going to be around 6%. But right now, it's going to be around 8.6%. So given the same level of vacancy, now the unemployment rate is even higher. There is still a negative correlation, right? This line is still negatively correlated. And even if you sort of eyeball it, you can sort of see that the slope doesn't really change too much, even if they change at all. But there's a shift. Okay? So, key observation here, first thing is that unemployment rate is countercyclical. So GDP high, low unemployment. GDP low, high unemployment. I mean, that's intuitive, right? I mean, when the sort of the GDP or the economy is bad, people usually see high unemployment rate. And then the unemployment rate and the vacancy rate are negatively correlated. That correlation is called the Beverage curve. And the last observation is that the Beverage curve shifted out during the last recession. Any questions? No? Okay. Now we come to our first model in this chapter. So, like the title suggests, this is a one-sided search model. We're going to model how an unemployment worker is searching for a job. That being said, so we're going to focus on the behavior of that unemployment worker. Okay. And this is the model assumption. First of all, unemployment worker going to receive a unemployment insurance UI benefit. We call it lowercase b at the beginning of each round. And then this person will receive a wage offer with probability P. That means it is not always the case that this person will receive a wage offer, only with probability P. That wage offer is going to be a random variable. Okay, that W, the wage offer, is going to follow a CDF, F of W, and the W is going to be bounded by 0 and W1. W1 is the upper bound. 0 is the lower bound. So the lowest offer is going to be 0. The highest possible offer is going to be W1. And this person can either accept this offer and work for this a wage, or turn down the offer and then continue to search. Okay. And if you are, this is for the person who's unemployed, right? For the person who is employed, employed worker has the probabilities S being separated from the job. That means basically he's fired. Okay, he somehow cannot do the job anymore, so he quit. And we consider an infinitely many period model. So all workers are either employed or unemployed in this model. Okay, there is no such thing as not in the labor force in this model. Like I said, keep the model simple. Okay, I mean, it's too complicated to consider the decision of whether to be in the labor force or not. So the agent's problem, I ask you to list the problem, that it shouldn't be too hard. It's basically a utility maximization problem. So at the time, so I have infinitely many periods, right? So actually starting which period doesn't really matter. Let's say just starting from period 0. From t equals 0, I maximize my discounted utility over all the period. So in each period, I will have utility U of CT. CT is my consumption. Okay, but in this model, we don't have any income other than the wage or the unemployment insurance. So CT is gonna be either WT or B. If he is unemployed, then that's gonna be B. If he is employed, then he will receive WT, means the wage in time T, because in different period, wage might differ, right? In this model, I could do something like this. I could start it as an unemployed and try to search for a job, and then one day I see a new wage offer. I see this is a high enough wage, so I join it. This wage, say it is $20 per hour. I accept it, and then I started to work that wage. And then after some period, I was separated from that job. So I become unemployed again. And then for some period later on, I got a new job offer that the wage right now is $30, and I accept the job. Then in both cases, I'm employed, but the wage is different. So I use WT here. But the B doesn't have a subscript T. Because if you are unemployed, no matter in which period, you're gonna receive B. Okay, and this expectation has a lower subscript 0. That means I'm doing the expectation from the time point of period 0. So I'm taking the expectation when I'm in time 0. I'm consider from t equals 0 to t equals infinity, many period. And this 1 over 1 plus r, that's just the discount rate. Okay, some people would define this as beta. So, I mean, that's just because we are infinitely many period, we must do some discounting. Otherwise, the whole utility is not bounded. Okay. So, in a way, if you have like a supercomputer or so, you can actually solve this problem directly. I give you all the essential information already. You can even write a computer program to simulate the best policy. Okay, but when people are developing this model, the computer is not that advanced. Also, that way actually makes the problem more complicated. Okay, so to find the optimal policy or solution, we actually want to use the technique called dynamic programming. Okay. Let's first give you the Bellman equation, and then we will have a break. And during the break, you can think about why the Bellman equation looks like this. Okay. Let's first define it. Let's say VEW is V stands for sort of value. Okay, that's like a utility function. We call it value function. Okay, so V is just a letter, stands for value. Okay, and E means you are employed. And the W here, the input W here, means for a person when he is working with the wage W, what is the sort of the value for this person? When I say value, what I mean is this person is employed, not just for this period, but from that period on, he's not always employed, but I mean, with probability 1 minus s, he will keep employed. So this is infinitely many period and discounted back. That's the total value for that person. I write VEW. It's obviously a function that depends on W, right? When the W is higher, obviously this thing is higher. And I say that the Bellman equation is going to be like this. So the value for you to receive a wage offer W or getting a wage offer W is going to be 1 minus 1 plus R. That's just a discounting. Discounted value of what? Of receiving W for one period times plus the separation probability times VU. VU is the value, the same value, but this time you're unemployed, so it's VU. And there's no VU of something. VU is not a function of W because, I mean, in a way it is a constant if you think about it. It shouldn't be dependent on W because it's, you're unemployed. And probability S, you're separated, so you get VU. And probability 1 minus S, you're not separated, and you still get the VEW. VE of W. That's the Bellman equation. And that actually sort of already give you all the answer you need with that equation. Okay, think about that, and we will explain to you why that's the case.